Relations are a point, x comma y. X is related to y. Every XY combination always is a relationship. However, there's one thing that happens when you have a function. So a function is a type of relationship. What the function is for every value of x, there is only one value of y. How can I explain that better? Well, I'm going to give you a couple different scenarios. And we'll get to this in a minute. Let's say I have, okay, I'm going to say this is my code. And this is, we're going to talk about like a vending machine. Vending machines are functions. Okay, I put in the code and I get out my, we'll call it candy. This is a candy vending machine. Okay, so let's say I have a code of 1. I get candy is M&Ms. Code 2, candy is Snickers. Code 3, candy is Almond Joy. Okay, so now, if I press 1, I know I'm going to get an M&M. If I press 2, I'm going to get a Snickers. And if I press 3, I'm going to get an Almond Joy. That's a function. This is basically saying this is x and this is y. For every x, there's only one y value. What if I say that if I put in a code and here's my candy. Remember, I have M&Ms, I have Snickers, and I have Almond Joy. And my codes for these are 1, 2, and 3. Well, if I press 1 and I get a Snickers, and I press 2 and it gives me a Snickers, and even if I press 3 and it gives me an Almond Joy, well, that's not so bad, because maybe in this vending machine, 1 also has a Snickers instead of an M&M. So notice, if this is x and this is y, for every x, I'm just getting one y value. I press 1, I get Snickers. I press 2, I get Snickers. I press 3, I get Almond Joy. That's a function. So this is a function. This is a function. Let's see what's not a function. So I put a code, 1, 2, 3, and I have candy, M&M, Snickers, and Almond Joy. Let's say I press 1 and I get either a Snickers or an M&M. And I press 2 and I get an Almond Joy. Well, that's not great, because what if I want an M&M? they're not going to give me 2 pieces of candy. They're going to choose for me. I don't really like that. If this is X and this is Y, then for every X, do I have only one Y? No, this X goes to 2 different places and the machine's going to choose which one it's going to go to. I don't get to choose. This is not a function. So if you set up something like this, that's how you can do it. So if we look at the first one, well, I know where 5 goes, only goes to one place. 2 only goes to one place. -2 only goes to one place. -4 only goes to one place, and -5 only goes to one place. This is a function. 5 goes to one place, 0 goes to one place. -4 goes to 2 different places. How do I know which one it's supposed to go? I don't. This is not a function. So with the last two, you can do one of 2 things. If you have one number and it's going to 2 different places, you already know it's wrong. If you like the visual from before, you can put down one of each number. The main thing is that you don't duplicate any numbers. So here we have 9, -9, 8, -1, and -8. Okay, I didn't duplicate any numbers. This is X and Y. And when I say don't duplicate numbers, I mean don't duplicate X's, don't duplicate Y's. But X's and Y's could have the same value. So 1 goes to 9, -9 goes to -9, -6 goes to 8, 1 goes to -1, 3 goes to -8. That makes this a function. There's not even an overlap, right? Let's see if the next one is a function or not. So again, I have 2, 7, 6, -7. I can't write that last 7. I already have a 7. So that's what I mean by don't duplicate. My Y values, I have 3, -7, -8, and +7. I'm not going to duplicate that -8. So 2 goes to 3, 7 goes to -7, 6 goes to -8, -7 goes to -8, and 7 goes to 7. This is the one that doesn't work because 7 has 2 different Y values. And remember, the definition is for every X, there's only one Y. Here for this X, 7, I have 2 different Ys. This is not a function. Another way we can tell whether something is a function is it passes the vertical line test. Because the way that the function is defined, I can also see it on a graph. So for example, if I have a graph that looks like this, and I put a straight up and down line everywhere, notice it's only going through one point. Here, that's going through 1 point, 1 point, 1 point. And no matter where I go, it's only going to be going through 1 point. This is a function. For every value of X, there's only one value of Y. What if I take the same graph and I turn it on its side? Now, when I make a vertical line, notice I have 2 points that line is going through. So if I say that a function is for every x, there's only one y, well, this value of x has two different y values. This is not a function. That's really all you have to do is you have to look at a vertical line. So if I look at a vertical line here, I could say, no, this is not a function because lots of places I'm going to pass through. I'm going to have 2 points. Graph 2, this is a function because there's no 2 points anywhere. This right here is also a function because for every vertical line, there's only one point that it passes through. Here, if I look here, okay, that none of these are on the same level. This is also a function. Doesn't matter where here I put a vertical line, it's only going through one point. But here, notice it's the same as basically what I drew over on the right. Everywhere I draw a line, except for at that very tip, it's going through 2 points. This is not a function. It literally only has to go through 2 points one time, and it changes from a function to not a function. And that's all there is to it when you have a graph. All right. So if I have, I have a relation here. They're not saying it's a function or not a function because functions are relations, but relations aren't always functions. Functions are always relations. Relation is the bigger umbrella. Under relations, you have functions and non-functions. Okay, if I were to draw that, it would be relate. It would be here's my relations. I would have functions or not functions. Okay, so everything is a relationship. Not everything is a function. So suppose we have a relation defined as follows. The domain means the x values, also called independent variables. They're called independent variables because usually if I have y equals some x, I put in x in and it's independent. Once I calculate that and I say what y equals, well, it depends on what x equals. So we call x the independent variable. And then we have range. Range is the collection of y values. Y is also called the dependent variable for the exact reason I just described. So I have, and it says answer with set notation. Set notation always has these curly braces. So I'm going to just put the curly braces in and then I'm going to put stuff between them. So my x values are 2. Can I put something between them? 2, yeah, comma, 5, comma, 4, comma, 3. I lost one. Good. Yes. 2, comma, 5, comma, 4, comma, 3. That's my domain. Range. I have a 7. I have another 7. I only need 1. 8, comma, 1. Notice I don't have to put them in any order because it's just a set of things. Sets don't have to have order. Oh, what did I do? 2, 5, 4, 3. Let me make sure. Hold on. 2, 5, 4, 3. Okay. 7, 8, 1. Okay. Let's see if there's something I have to do to put it in different. No, I don't want to do that. Show detailed solution. Just want to see how they put it in. Oh, I see. No. No, that's not the reason. Hold on, let me see what I'm doing wrong. Oh, they do want it in order. By the way, it doesn't have to be in order. But for this software, oh, it says, that's my fault. It says write your answer using set notation with the elements in ascending. That should be a D, order, and no spaces. So it was just my mistake. You do not have to put them in order, by the way. Okay. The answer I have is right, but they wanted it in ascending order, which you just have to put 2, 3, 4, 5. We have the same numbers. 1, 7, 8. We have the same numbers. I can't seem to figure out how to make it give me another question. So sorry about that. All right. Now I have 2 functions, and I want to know what g of 2 is. So I'm going to do this with colors. It makes it a little easier. So if I know that g of x is equal to -4 times x minus 1. I'm going to rewrite this one more time. This is really just for demonstration purposes. You don't have to do this in real life, but here's an x and here's an x. That's our original equation. What g of 2 means is I'm going to replace my x's with a 2. That's it. That means g of 2 is equal to -4 times 2, which is -8, minus 1, which equals -9. So this is -9. Now, I know some of you are going to think, those parentheses aren't that important. Trust me, they are. Because what I want to do is I have -3x squared plus x minus 4. I'm going to write it one more time. So here, if I say this is x, I go back to my original equation. If I say this equals -1, now we have negative 3 times negative 1 squared. So that would be positive 1 plus minus 1 minus 4, which equals negative 3 minus 1 minus 4, which equals negative 8. Okay, now if I didn't put my parentheses, let's see what would happen. I would have f of x, or f of minus 1, is equal to negative 3. I don't know how I would do that. Negative 1 squared times plus minus 1 minus 4. Well, when we did exponents, I don't know if you remember, I showed you that the exponent only really affects what it's next to. It's only next to the 1 here. This would be like saying negative 3 times negative 1, because I'm only squaring the 1. I would still have the negative, so it'd be negative 1. And then plus minus 1 minus 4. This equals 4. Right? This equals 3. Minus 1. Actually, plus 3, because negative times a negative. Minus 1 minus 4, which equals negative 2. Look, it should be negative 8. I got negative 2 because I didn't use my parentheses correctly. You might say I would know it, but there are times when the functions get a little more complicated that you may not know it. So really put the parentheses in there. It'll really help you a lot. This is really exactly the same. I'll do it because it looks a little different, but it's exactly the same thing. So if I say f of whatever equals 3 parentheses minus 1 over 5 parentheses minus 2, whatever's in the x, we're going to put whatever's inside that thing, we're going to put where all the x's went. This is really like saying x equals 6z. The last one is like saying x equals 2 for g of 2. X equals negative 1 for g of 1, for f of 1, for f of negative 1. So this equals 18z minus 1 divided by 30z minus 2. And put it in. I'm going to put parentheses. You can see on the right whether or not yours would work without parentheses. Okay, that looks not right. Okay, see, 30z, I have to put parentheses around that. Because without it, it doesn't know you mean the whole thing. So I have my numerator, 18z minus 1, my denominator, 30z minus 2, and the way I tell it is using parentheses. I'm not going to do this for you. Basically, it's telling me that B books is given the following. So she's going to, if she sells B books, here she sells 58 books. I just put B equals 58 and I get 98. That's it. So there's a setup charge of $11. That's what this 11 is. And I paid 20 cents per copy. So if I want to know if I make 20 copies, then X equals 20. And you just multiply this by 20 and you'll get $4. So this will be $15. I'm not going to really spend time on it. If you have questions, you can always come see me. You can always come ask me anything. So here, this is important. F of minus 4. You know what I'm going to do? I'm going to snip this so I can actually write on the screen. Okay. So here I have the graph of a function is shown below. F of minus 4. Remember we said F of something, and then what we did is we put in our X here, and we're putting in our -4. Notice that means that X has to equal -4. So we go here to X equals -4. We go down and we can see that when X equals -4, Y equals -4. I can't put it in here. So this would be -4. There's another way they can say that. They can say F of X equals -3. Well, now what I'm saying now is that Y equals -3. This is the same as Y. So if Y equals -3, I'm here. They'll ask me what X is. X would be also -3. That's how that works. So if they give you F of X equals something, they're really saying Y equals that thing. And I go to where my Y equals -3 and I find what X is. If they're giving me what's inside, they're actually giving my X value and I want to know my Y value. So -4 is the answer here. And I'll assume that they do this in the other one here. The graph of a function h is shown below. Find h of -1. So now X is -1. I go here, I go to -1. When X is -1, Y is 0. Actually, I think I can do this. Yeah. So I'm here. Okay. That means Y equals 0. One value of X such that h of X equals 2. So h of X again is my Y value. That's my Y value. Here's where it equals 2. So I'll come down and say, here's where X equals -2. And here, Y equals 0. 0, -2. And that's it. That's my last question. Thank you for watching. And hope to see you in the next lecture. Bye.